If you're looking for a content sharing the atmosphere of KubeCon and having a couple of interviews, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is a bit special because it's going to be dedicated to Kubecon Europe Paris 2024. And if you pay attention, I already released 2 episodes related to the conference. And because I did so many interviews during the conference, I have the options to deliver a 3rd episode about KubeCon Paris 2024. You may say, yeah, you already did that for Chicago. Yeah, that's true. So why not do it for Paris? In this episode, I will cover a few topics. So we'll have KCD Austria presenting their conference. We will look at the updates about OpenTelemetry Profiling. We'll have also some exciting updates with Odigos. If you remember, we did an episode dedicated on Odigos. And we will also cover and present the solution Cast.ai. If you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in Paris. Last day of KubeCon, a few more interviews to run, and it's going to be half a day because I have to travel back to south of France, so it's going to be a much shorter day than the other days. So yeah, everything comes to the end. Pretty amazing KubeCon, I think.
My name is Ryan Perry. I am a director of product at Grafana Labs. Previously, I'm one of the founders of Pyroscope, an open source continuous profiling solution. There's a lot going on with profiling inside of Grafana. One of the reasons that we decided to join Grafana as Pyroscope is that we really thought that there was a high ceiling that we had for what we could do with profiling when you combine it with logs, metrics, traces, load tests, a lot of the other suites of products that exist within the Grafana Labs and Grafana ecosystem. And so we've been doing a lot with finding ways to basically integrate profiling into your workflows without you necessarily having to go and query your profiling database for that information. There's a lot going on with the profiling signal in OpenTelemetry. We've made a lot of really great progress. We started the profiling SIG almost exactly 2 years ago at KubeCon in Valencia, I believe. And since then, we've spent a lot of time evaluating what the best format is for profiling data and the best way to collect it. And most recently, we were able to basically merge the format for profiling so that we now have a standardized format, which opens the door for being able to now create language implementations for the various languages and be able to basically bring profiling to many more users than were using it before. As far as timeline goes, you can definitely expect something this year. We're trying to figure out exactly how far we can get. Like I said, now that we've kind of gotten past the biggest hurdle of defining the profiling signal itself and the format, It's just a matter of implementation now. And so there's been a lot of participation from a lot of different companies and finding ways that they can help us kind of get to that end goal. But I would say definitely in the next like 6 months or so, you can expect to be able to see some language implementations. We're in this experimental phase. We want people to really kick the tires and let us know their feedback on how it works for them and how it meshes with the way that they're using OpenTelemetry in general. And yeah, you'll be able to do that sometime later this year. The collector is obviously a major part of OpenTelemetry, and so being able to support profiling in the collector is something that we've talked a lot about. Yeah, receivers, exporters, all the different components of the collector. And I would say that that's one of the benefits of the collector, is that you can extend it in any way that people will see fit. In the initial stages, what we're thinking a lot about is how we can add a couple of just base features, being able to add and remove labels, being able to do some sort of sampling, things like that we know people are going to want to do from the conversations we've had with the community. And then from there, we're going to kind of expand after we get some feedback and go into more advanced use case, perhaps something related to how we deal with symbols for profiling data or other things that are more advanced. But we're going to start with some of the more basic use cases that we've already heard that people want to have. The best place to get information related to profiling and profiling specifically within OpenTelemetry is going to probably be our Slack channel on the public Slack. I think it's just hashtag OTEL profiling. And but then also, if you're paying attention to the Twitter, to LinkedIn, wherever they, kind of do the communications for OpenTelemetry, whenever we do something major, we'll make sure to put it there. But if you want to follow along in between, I would definitely say the Slack is going to be the best place to go.
Emin Alemdar. I'm a CNCF ambassador and one of the organizers of KCD Istanbul and CNCF Community Group Chapter Istanbul. We have our second KCD in Istanbul. It's going to happen in May 15 and 16. And we have speakers from all over the world, and we have some great keynote speakers such as Liz Rice, Kat Cosgrove, and of course Ayşe Kaya as well. We have both Turkish speakers and also foreign speakers. We will have sessions in English and Turkish. We are trying to gather the community around to learn more about cloud native technologies actually. We had our first KCD last year in Istanbul, and it was a huge success because we had around 500 people attended to the event, and we are expecting around 400 people this year as well. We will have 2 days for the event, May 15 and 16th. We will have single track for both days, but we will have talks about security, talks about AI, talks about Kubernetes operators, and of course we will have talks about networking as well. We were working with the Cloud Native Community Group by organizing meetups, online and in-person meetups for the Cloud Native Community Group chapter. We thought it was about time to organize a KCD as well in Turkey because Cloud Native community is growing really fast. And last year we decided to come together with people from different companies, and we have some CNCF ambassadors. Not just myself, in the organizer group as well, and we found some great sponsors to help us with the venue, with other stuff as well. But Cloud Native community in Turkey is growing really fast, and we want to be there for them. The first KCD, we had multiple challenges. Actually, we had an earthquake, like a huge earthquake in Turkey. That's why we had to postpone the event, change the time. And we also had a general election So it was a bit difficult for us to actually organize, the accommodations, the logistics were a bit tough for us, but it was a huge success at the end because cloud native community in Turkey was really keen to actually support this KCD. If someone wants to organize a KCD event, please don't hesitate to reach out to other KCD organizers and also CNCF as well, because they are always there to help you. They're always there to share their experiences from the past, and we love each other, right? We love each other's company as well. So please don't hesitate to reach out to other people. They'll help you get started very quickly. So they can reach out to us from our social media accounts. We have social media accounts on LinkedIn and Twitter, X nowadays, but we also have a website too. It's kcd.istanbul. It's very simple. They can reach out to us from there, and they can seek information.
In OpenTelemetry in the Go automatic instrumentation special interest group. I'm also the CTO of a company named Odigos, which helps with automatic instrumentation. And yeah, happy to be part of the OpenTelemetry community and doing whatever I can to make distributed tracing as easy to use as possible. So we are coming with some very exciting updates to Odigos, the open source version, here in Kubecon. There are two main areas that we are focusing on. The first one is the instrumentation. We really want to take automatic instrumentation to its full effectiveness and full power. We are doing context propagation in places that was not possible before. We started with Go. We're now doing it in additional projects, in additional open source products. We're now doing it to additional libraries like Kafka producer and consumers, all with eBPF and without any code changes. And the second area that we are focusing on is making working with the OpenTelemetry collector as easy as possible. We came out with a new feature called Odigos Actions, which are like kind of recipes for different use cases that you want to achieve with the OpenTelemetry collector, like adding additional attributes, filtering sensitive data. All of this can be done very easily without having to write long YAML files and being an expert in OpenTelemetry configurations. The action feature is something that is just came out. We now started with like 4 different actions to adding additional attributes, removing attributes, filtering different attributes, but we're constantly adding more and more use cases, like again, converting traces to metrics, or like changing the metric format from Delta to like Prometheus. So we are constantly adding more and more features and more recipes and actions. So if you have ideas for more actions we can add, feel free to reach out, and we will be happy to add more use cases and more actions to the project. So basically the actions in Odigos are a custom resource in Kubernetes, so you can simply write a very thin, a very little amount of YAML, which is a custom resource for Kubernetes, and Odigos will automatically convert it to the configuration for OpenTelemetry collectors, meaning you can just like specify, I want to add these attributes, I want to delete these fields, and Odigos will automatically generate the OpenTelemetry configuration for the collectors that you deploy. Again, making it much more easy to work with use case specific custom resource instead of like generic YAML files that describes the whole pipeline and the whole configuration for the collector. All the information about all the new features can be found either in our GitHub repository, which is keyvaldev/Odigos in GitHub, or in our documentation. We have a pretty good documentation at docs.odigos.io.
KCD Austria, and super excited to be here. We had the first edition last year in autumn, and this year we will have the second edition in October. It will be on October 8th to 10th, so we're going to host it in the cinema again, so you can prepare for big screens, for amazing comfy seats. I saw it last year, it was very special for all the speakers coming in. You have the huge cinema screens. You just have a great audience there. It's really a special thing to speak there, I guess. And I was a volunteer last year, and I thought I wanted to join that group of people organizing such a great event this year. And so I asked if they needed help, and luckily they did. So I'm part of the group this year. I have always been a huge fan of communities. So I'm part of a local inline skating team for 15 years now. And I just enjoy people coming together, having the possibility to also give back to communities. And I thought being part of the organizer group gives me exactly that chance. It's a lot of fun so far. Follow us on LinkedIn. We're going to start posting regularly about the event in autumn there. And we're looking forward to seeing you on any channel.
My name is Kuperman. I am the Chief Technology Officer at Cast.ai. We are a scale-up company that is focusing on Kubernetes automation and specifically around how to save our customers money when they're running their cloud-native environments in AWS, GCP, and Azure. In the industry, there are different FinOps solutions, and how do we differ from other solutions in terms of the price accuracy that we provide to our customers via our user interface and our APIs. Initially have an estimation of costs. So what do? We use list prices from the 3 cloud providers, and that includes both spot prices, on-demand prices, but then as our customers integrate with us more deeply, we then start using the billing API from Google, for example. We start using PER or current usage, cost and usage reporting, and we specifically import things like reserved instances to give customers a better sense of what they're actually spending. And then all of that integration then trickles down to all the way down to the workload level. It's important for us because when we get into automation, we're making decisions based on the cost of computers. And when you have a reservation that is already a sunken cost, we need to fully utilize those before we can make other decisions, even though they might be cheaper at list price. So how do we measure and calculate costs? What do we have to deploy in our customer environments, in our user environments? We start with a read-only agent. That agent is a deployment that goes into your clusters. It is open source. You can go to our GitHub repo and look at the source code. And what it does is it sends snapshots back to our SaaS platform. That includes metadata around the nodes that you run, the types of workloads, the storage that those workloads are attached to, and many other details. And so that agent is used to do the first level cost estimation. And then as you get deeper into the integration, as you start turning on features, we then get some privileged access around a workload that we deploy called a cluster controller that allows us to do things like drain and delete nodes. And then we also get some cloud API access. So for the 3 clouds, we ask for IAM permissions to pull things like billing data, for example. We also have compute permissions to allow us to spin up computers and then remove them. And there's a host of other permissions. All of those permissions are located in the security tab in our documentation so customers can transparently see what we're asking for. So what do our users do to expose the data that we collect to other solutions like application monitoring platforms or other infrastructure monitoring platforms like Splunk or Dynatrace or Datadog or others? So the great news is we've really heavily invested in OpenTelemetry over the last couple of years. So for example, all of our logging features are exposed through OpenTelemetry, and you can basically pull in all of our event logs into whatever logging platform of choice that supports OpenTelemetry. We have a Prometheus scrapable endpoint that allows you to scrape all of our cost metrics. So while we provide some nice dashboards, we don't expect people to use our dashboards as the sole source of truth. We want them to import our metrics into their platforms of choice, whether that's Prometheus or or Dynatrace or Splunk or any other observability tooling. Let me briefly show you the solution and walk you through maybe some of the basic capabilities, and then we can take a deep dive if it's interesting to users. So what you're seeing on my screen right now is a cluster list. These are 2 clusters that I've got connected on 2 different platforms. Actually, I think one of them is on Google and one of them is on AKS. This one is showing orange because it's actually in what's called a hibernated mode. We have a feature that allows you to pause your clusters, for example, on the weekend when you're not using them. That typically saves 2 out of 7 days. Pretty easy and quick win. Let me show you the one that I've got up and running on this desktop. So right now, I've got a typical cluster as it would have been created. It's got 5 nodes in it. They're all managed by EKS. And one of the interesting things, you can see that they're about 66% over provision based on this dashboard. Now, you might say, well, Leon, is that realistic and that is the typical number we see. And the reason for that is because the Kubernetes scheduler is very fair. So as many nodes as you give it is as many nodes as it will use for those workloads. So you need to really do some concentrated work on bin packing and fragmentation removal in order to get that cluster reduced. Now what I'm going to do, I've deployed a workload on this. We can actually see, let's just walk through. We can see that the number of total CPUs requested in this cluster are 3, but there are 10 of them that are provisioned. I'm showing this to you on a small example, but now imagine that in your dev, staging, or production environments, how this will affect. This donut is a typical shaped donut for what we see from our customer environments. We see that on memory and CPU, and if we were using GPU, we would see that for GPUs as well, which is a key statistic. You also see it, like if we scroll into 7 days, you can see how this cluster has kind of evolved in a non-Cast.ai environment. And really what you want to focus on are the differences between the line and the area. The white space is really the waste that you have in your cluster, both from a memory and CPU perspective. And our goal will be to remove that waste in this little demonstration. So let's take a look at how to do that. We start with what's called an available savings report. So from a monetary perspective, how much money is on the table that you could be saving? And so what we see, let me turn off all of the widgets. We see that this cluster is costing us about $350 a month, but like, can we do better? And so this configuration shows you like, all right, rather than running 5 M5 extra large instances here in this configuration comparison area here, we should be running C6A, large and extra large. Now, you can see that this instance recommendation is interesting because there's no concept of node pools in our product. We actually think node pools are an anti-pattern that need to get eliminated. And the reason is because you're playing a game of Tetris with your cluster in a sense. And not all Tetris pieces come with the same shape. They come with the shape that is required to fit the gap in your cluster. So we sometimes recommend very, very odd-sized computers just to match exactly the workload that you need. Let me show you how that works. But before we do that, I just want to show you a couple of other knobs that we have in the... So right now we're showing that we're at 63% kind of progression to optimize. But what happens if we decide we want to use spot instances in the cluster as an example? So let's turn this on. And we can see that, sorry, not workload eraser, so spot instances. We can see that, okay, now we have an extra 30% of the cluster that we can save. So now instead of being 68% optimized, we're only 30% optimized. I could also, for example, select spot-friendly workloads. What are spot-friendly workloads? These are workloads that have multiple replicas, so if they're interrupted, the service will not go down. They're workloads that don't have a lot of persistence, so that moving them is not difficult. So we're looking for ease of movement, essentially. And we can actually look at those workloads, and you can see that I've got 2 suggestions. I've got 2 workloads or a set of pods that can move from on-demand to spot. So let's take a look at how we actually can achieve these savings. There are other toggles, by the way, for like graviton usage if you wanted to see what Graviton would affect your costs. We have cluster schedule, which we showed you in another cluster, and shows you how to affect those costs. And we also have this thing called workload right sizing. So workload right sizing is really interesting because everybody guesses at the types of requests and limits you want to place on your workloads, and that's just a guess. And we call this the sandbagging effect. So let's say you have an engineering team and a DevOps team. So your engineers are going to first set some requests and limits that are going to be safe, and they don't want to get woken up in the middle of the night. And then your DevOps team is going to sandbag those values and say, okay, well, maybe we should increase them by 20% because we don't want to get woken up in the middle of the night as SREs. So you end up with this very inflated set of additional costs on requests and limits, and our platform reflects that. So there's a separate module that works together with the whole scaling platform that shows you how to reduce those requests and limits so that you can get to optimal state. Maybe I'll show that to you in another environment with a lot of data. When we get to a place where we can actually start saving money, all you really need to do is you need to turn on the scaling policies for Cast. So I'm going to do that right now. There's only 3 policies to worry about. Unscheduled pods. There is node deletion. And there's CPU limits. But for the purpose of this demo, let's just show 2 things. And now I've got a lot more detail of nodes that I can provision beyond these kind of simple settings. I'm not going to go into it right now. Let's just go ahead and save the changes. Now our autoscaler is fully active and ready to save us money. But how do we get that 30, 40, 50% savings that we were initially promised on that savings report? The way we do that is we can do that through what's called a rebalancer. The rebalancer is, think of it as a macro optimization that gives you a one-time, immediate bin packing and resizing of the entire cluster. I'm going to do that by preparing a plan. And I'm going to select the 2 nodes that we have. Actually, we should have had 5. Oh, there's some that are cordoned here. It's interesting. I turned on the autoscaler and it immediately started optimizing out 3 of the nodes that weren't being used. So I didn't actually get to show you the full pop, but let's take a look at, so these are actually being corded and now being deleted because there was waste on them. The reason we started seeing that benefit almost immediately is because we turned on the evictor and it was running, and we had a very low node TTL. And so we had a TTL of 0 minutes. The evictor kicked in right away, found the waste in the cluster. If we go to savings, we'll see now we're 100% optimized at $140, down from the 350 or wherever that we were at. And I didn't actually have to do the big operation of what we call rebalancing. So this is just kind of a glimpse of the capability of Cast. We probably scratched 10% of the service, but it gives you an idea of the level of automation that we're working with in the platform. So how can you try the platform if you just want to test and play? So the great news is just go to Cast.com. There's a sign up button in the right corner, and there's no gate. You just sign up through a single sign-on, Google, GitHub, or email. And then you'll be given access to the entire platform. You can connect clusters, you can try out the automation, and you can go as far in the journey as you want without speaking to anyone in sales or marketing. So the great news is it's available for the community to try out and see where the real value is. So how do you get more information about Cast? There's a lot of detail on the platform, and it sometimes helps to get a guided tour. So of course you can sign up, look at the documentation, look at the API spec, look at our Terraform provider and our cross-plane provider, and get started by yourself. But if you want a little bit of guidance, if you want to see a demo of the platform, on the Cast.ai website, we have a book a demo widget. Just go on there, you'll be speaking to an engineer who understands Kubernetes deeply and can help you walk through all your particular edge cases, all your specific use cases, and everyone has their own specific nuances in their own deployments. So one of the things that we've released just in time for Kubecon is something we call our spot availability map. I want to just walk you through it to show you some of the basic things. This is available for free as a resource to anyone that wants to take a look at it. It's basically a map of the world across 3 cloud providers. So for example, if we show AWS or Azure, the map changes according to the regions that they have. But let's focus on AWS for a second. And let me zoom into the map to Europe since we're in Paris. Here. And what this shows you is right now I'm using a metric called spot interruption rate. And you can click on a region and you can see that in EU West 1B, for example, 9% of the spot instances in that specific region across all availability zones were interrupted in the last 12 hours. But we can also look at an interesting metric around insufficient capacity errors. So when you're provisioning capacity, where are you getting errors? And it looks like a lot of the regions are green, except for maybe Frankfurt, it looks like. But also very interestingly, you have a spot price predictor that tells you in the last 12 hours, how have spot prices looked? And we can see that, for example, in Spain, we've got really good pricing. In Italy, we've got really good pricing. These are 1.7 cents per CPU core. But if you look at Ireland, for example, it's much more expensive at 3.8 cents. Now, it's great as a visualization because you can start to see how dynamic the world is in terms of compute, cost, and attainability. But ultimately, you're going to need an automation platform that helps you leverage this type of data and move your workloads across AZs to the cheapest possible areas. But this is kind of an example of where dynamic machine-driven decision-making is extremely critical because you can't expect humans to keep up with the ever-changing world of cloud, FinOps prices, availability, interruptions, and many other factors that are required to make decisions as to where to deploy your workloads.
That's it for today's episode related to the conference Kubecon Paris 2024. Very excited to hear all the updates related to OpenTelemetry Profiling, and I'm really eager to see the first implementation on the OpenTelemetry Profiling support. I think it will be a great excuse to deliver an episode once this is released, because at the end, everyone is expecting this, having the ability to cross-correlate between profiling, metrics, logs, and traces. That will be just fantastic. Odigos did also really interesting updates to, again, simplify our journey with OpenTelemetry to make the collector experience even better. So I think it's also going to be excited. It deserves to be also looked at deeply by doing a deep dive, for example, maybe a short updates about Odigos. Last, I think the Cast.ai platform is really interesting. I was really surprised with all the various options we have to optimize the actual costs and of course the energy usage of our Kubernetes clusters, and also the options to utilize spot instances and having a direct understanding on where the spots are less expensive to spin up the spots in the right geo. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. Thank you for watching, and see you soon for a traditional episode. Bye.